There's been a lot of talk in the news lately about astronomers looking for signs of life in outer space. We just recently discovered signs of liquid water on Mars, and Saturn's moon Enceladus has a salty sea under its crust, both of which could contain some form of life.
But we don't want to just find life, we want to be the life that lives there. None of the planets in our solar system, besides Earth, are fit for human habitation outside of a spacesuit. We can build space stations and all the colonies we want, but what I really want to find is a habitable planet we can live on. A planet with an atmosphere we can breathe, a planet with oceans and water and maybe even life.
But is there another Earth out there?
And how can we find it if it's trillions of miles away?
My favorite planet is a huge mystery right now. It's a planet called GJ1214b.
This is Laura Kreidberg, grad student and planet hunter from the Bean Exoplanet Group at the University of Chicago. And 42 light years away is GJ1214b.
Not the most catchy name.
Actually, it had a nickname for a while. They called it Kevin when it was first discovered because there's no planet like this in our own solar system, and so we were trying to figure out what it might possibly be based on its mass and its radius alone. And there's one really exotic explanation for the composition of the planet, which is that it could be like a water world.
Water world.
And so they were like, well, if it's water world, we should call it Kevin after Kevin Costner. So it's still a big mystery. Like, it could still be a water world and we don't know. And so that's, if I could pick any one planet to look at in more detail, it would be that one.
Kevin.
My favorite. Yeah, Kevin. Yeah, so my work is mainly focused on studying the atmospheres of exoplanets, so planets orbiting stars other than the sun. And exoplanets is just like the most exciting thing. There's so much new science coming out. It's a very young field, and so every day, I mean, even since I started grad school 5 years ago, the field has completely changed. We know now that Earth-like planets are incredibly common in the galaxy, and we did not know the answer to that question 5 years ago.
That's right. I got into the field of exoplanets basically when it was starting.
This is Jacob Bean, professor of astronomy and astrophysics at the University of Chicago. He's the leader of Laura's Exoplanet Group.
When the first planets were found in 1995, there were two things that kind of came together to make that happen. One was new technology. Things like CCD detectors, the same kind of detectors that are in these video cameras that you're using. So those were very important. These new technology allows you to record more data more precisely, but also it was the serendipity of finding planetary systems unlike any that were expected. It was having an open mind and going out there and just looking and saying, even though our technology is not good enough to see the solar system, maybe we can find planets that we don't really expect to exist. And so that's what happened. They found gas giants like Jupiter, but not way out in the outer parts of the solar system. Instead, they found them right next to their host stars, and that made them very easy to find.
But as detection techniques have improved, it's become possible to find more planets of all shapes and sizes.
As of the recording of this video, nearly 2,000 exoplanets have been found, and more seem to be found every day. There's one. Nope, that's the ceiling.
There are tons and tons and tons of planets out there. Virtually every star has at least one planet. We found just an insane diversity of planetary systems, totally unlike anything we have in our own solar system. So we found planets orbiting 2 stars, just like Tatooine in Star Wars.
Yeah.
And we found planets with incredibly short orbital periods, so less than 24 hours to make a complete revolution around their host stars. And so some of these are so hot that they're actually in the process of disintegrating.
Because they're so close to the star?
Yeah.
But we've also been able to find more Earth-like planets.
Meaning planets that are similar in size to Earth, have a solid rocky surface, and orbit at that sweet distance from their star where liquid water is possible. A handful of planets that fulfill this criteria have been found. Most of them are just slightly larger than Earth, falling into the category of super-Earth, like Laura's favorite planet, Kevin, or a mini Neptune, somewhere between 1.5 to 4 times the size of Earth.
However, it's estimated that our galaxy holds up to 40 billion Earth-like planets. And it still took me until college before I got a girlfriend. Kepler 438b is the most Earth-like found to date. Even though it orbits a red dwarf, a star much smaller and cooler than our sun, its mass, orbit, and composition all suggest it has more in common with our home planet than, say, Mars. But they haven't found an exact Earth analog.
Not yet, anyway.
And there's a couple different ways we look for them. One is to very, very carefully monitor the brightness of a star. And if there's a planet that passes in front of it, so it transits, then a little bit of the stellar flux will be blocked. And so it looks a tiny bit dimmer. And so if you make this really, really precise measurement of how bright the star is as a function of time, you can detect planets that are transiting that way.
How precise does it have to be? Because it seems like a planet wouldn't block that much.
That's a great question. So it depends on the size of the planet and the size of the star, right? But for a Jupiter-sized planet orbiting a star like the Sun, the drop in brightness is actually about 1%, so it's not that small. But for an Earth-like planet transiting a Sun-like star, it's maybe 100 parts per million difference. It's a really tiny signal.
And the second method, measuring the Doppler shift.
So the Doppler shift is the change in sort of color of the light that you're getting from an object, given its velocity either towards you or away from you. The analogy is how you hear an ambulance siren, how it appears differently when it's coming towards you and when it's going away from you. So what you're seeing in the situation of an ambulance is compression or elongation of sound waves from the siren on the ambulance. Light is analogous to sound in some ways in that it can travel as a wave. And so the wave can be compressed and elongated if the object emitting the light is moving towards or away from you. Over time, we can see the star being pulled by the planet in its own little tight orbit in the center of the planetary system. And if you plot this, it ends up with a nice sinusoidal pattern, a wave that looks like it's constantly repeating. And so that's the heart of the measurement, precisely measuring the change in color of the light.
And this is just a tiny, tiny little shift. Like for reference, an Earth-like planet orbiting a Sun-like star will induce a motion of about 10 centimeters a second.
But 10 centimeters in relation to something the size of the Sun is so tiny.
It is so tiny, yeah. So you have to build these insanely, beautifully engineered detectors to be able to measure these absurdly small shifts in the wavelength.
Although the first exoplanets were discovered by measuring this Doppler shift, the overwhelming majority were found by catching a star dimming as a planet transits. This is because most exoplanets have been found by the Kepler Space Observatory, and it uses the transit method to detect these planets.
Well, the ultimate step for planet hunting is finding a true Earth twin. That's a planet that's rocky, that's receiving the same amount of irradiation from its host star that our own Earth does, that has an atmosphere that's capable of causing the temperature on the surface to be appropriate for the presence of liquid water, and then ultimately seeing if there's life on that planet. And I think that's within the grasp of the current generation of astronomers, to find that kind of planet and then probe its atmosphere and look for the telltale signature of life, so-called biosignature gases, the kinds of molecules that would be in a planet's atmosphere only because life put them there.
An example of this on the Earth is that we have simultaneously in our atmosphere, we have oxygen and methane. And if you put oxygen and methane together, they explode. And so the question is, how can you have so much oxygen and so much methane without them reacting to produce something else? And the answer for the Earth is that the oxygen is produced by photosynthesis and the methane is mainly produced by methanogenic bacteria. And so what we look for on other planets is the presence of different gases that would not be expected to exist in chemical equilibrium with each other. And so there would be some kind of method, something producing those that could maybe be life. And it's hard, right? Because even if we detected a planet exactly like the Earth and we found methane and oxygen in its atmosphere, that wouldn't necessarily be 100% proof that it was inhabited. But the fact that there are so many planets that we can look at, there are tens of billions of Earth-like planets in our galaxy alone. Our hope is by using that huge sample size, we'll be able to start addressing this question of whether any of them are inhabited and how many of them might be inhabited.
How do you do that? It seems crazy that you'd be able to detect the atmosphere of this tiny planet that's, how far away are these?
Yeah, hundreds of light years, so very far. So one technique that we use is that we look at transiting planets. So the planet passes in front of the star, and when the planet is in front of the star, a little bit of the starlight is filtering through its atmosphere. And some of that starlight can be absorbed by different molecules that might be in the atmosphere, and we can work backwards based on how big the planet looks, how much of its atmosphere is absorbing light, to figure out what molecules are there.
It seems crazy that's even possible.
Yeah, it's really a marvel of modern engineering that you can build a detector that is even capable of measuring these things.
But have you found planets that would be, or possibly habitable?
Yeah. So Kepler, that was Kepler's job, is to discover Earth-like planets with temperatures that were suitable for liquid waters, and we found a couple, but they're mainly too far away for us to be able to study with these techniques with Hubble.
But in the future, it is the hope that we'll be able to look at the atmospheres of these planets by building bigger and better telescopes.
The field of exoplanets has grown enormously in the last couple of decades, and we're still poised for even bigger growth. NASA is going to be launching new space missions, the TESS mission to find new exoplanets.
That's the Transiting Exoplanet Survey Satellite. It uses the same method as Kepler to find exoplanets, but scans a much larger portion of the sky. Almost 500,000 stars will be surveyed. Kepler only looked at about 145,000 stars.
The TESS mission will pave the way for this mini Star Destroyer.
No, that's the James Webb Space Telescope.
Well, it looks like a Star Destroyer. I guess I got Star Wars on the mind.
Yeah, let's go get tickets and get in line.
Yeah.
The James Webb Space Telescope, which is sort of the intellectual successor to the Hubble and Spitzer space telescopes, will allow us to look deeper into the atmospheres of planets. And so even over the next 10 years, we're poised for new revolutions in our understanding of planets around other stars.
It's possible even to build an array of space telescopes that would be able to map in such detail, such fine spatial resolution on the sky that you could actually get like a 10 by 10 pixel map of the surface of a nearby Earth-like planet. And you could maybe resolve continents and oceans with data like that. And I would love to see a mission like that launched within my career. It's very humbling to think about how big of a place space really is and whether we're alone in it or not. And I think that self-reflection is really valuable for humankind as a species.
I think just trying to understand our own existence in the context of the universe is one of humanity's most fundamental questions. And I think looking for other planets, seeing if life has arisen on those planets, and characterizing what that life is like is just an important part of answering that fundamental question. It's a question that humans have wondered at least for millennia, since the ancient Greeks. And now we're in this position to start answering it. I couldn't think of anything cooler to be doing right now, actually.
What do you think? Is there another Earth-like planet out there just waiting for us? Or should we be looking for more Kevin Costner-like planets?
Or Kevin Spacey-like planets. Or if we do find Earth 2.0, will we be able to get there?
Oh, wait. Let's wait for the next video to talk about that one.
Okay, don't answer that question. You don't know. Maybe you know. Tell us. But don't tell us.
Yeah, just wait.
Just wait. Thanks for watching. I wish there was some way, if you enjoyed this show, you could support it.
Yeah, what do you think they could do?
They could probably go to Patreon, which is linked right up there.
Try it out. Last week we looked at some lunar rovers and going to the moon, and here's what you guys had to say about it.
Good work, Matt.
Thank you.
Jared Wenvent was concerned that people might not be able to live on the moon because their bones would wither away. Well, bone loss would be a real problem on the moon. Because of the moon's low gravity, astronauts would experience bone loss and muscle loss. However, it wouldn't be as bad as those who live on the International Space Station who live in zero gravity. And they've been able to live there for upwards of a year or more. And there are exercises that they can do to help slow the bone and muscle loss. The moon has 1/6 the amount of gravity as Earth, which is more than zero. So we don't really know how long one could live on the moon, but it seems like it could be for a pretty long time.
Anthony Raven Edmonds asked if the first moon colonists would be like early pioneers, or would corporations and governments claim all the land for themselves? Well, it'd probably be more like Antarctica, with a few isolated research stations operated by institutions or corporations or governments. The thing is, it takes a lot of resources and money to get to the moon and live there, more than the average individual has on hand. Early pioneers just needed like a horse and buggy and not get dysentery. So barring the super rich or mega billionaires, the moon will be colonized by robust institutions with a lot of capital at their disposal. There is a moon treaty, however, which basically says that no one can own the moon and anything discovered there should be used for the good of humanity as a whole. But it hasn't been ratified by any country that's actually been to the moon, so it doesn't have much weight. While Benzene Town is a great name for a city,
You know it.
we're more likely to see something like the Google Research Outpost.
Damn it. Ownbrutch22 is concerned that a can of soda would instantly burst in the vacuum of space. Well, technically the can contains a powdered version of the drink that future astronauts or people who live on the moon, mooners, could add water to make a delicious liquid carbonated beverage to drink with their breakfast, lunch, or dinner. However they want to drink it. They could dump it on their head if they want. That'd probably be wasteful. Thanks for watching. Our next video next week is all about
A warp drive being built in some guy's garage. Does it work? You'll have to find out.
We know because we already shot it.
But you'll have to watch it to find out. Next week.
And my knee cracked.